Oh, hello everyone. Let's get started again. In the last video, we discussed the physical meaning of dot product and cross product. So now I'm going to extend this discussion further uh, to discuss uh, something called triple product, or it's called scalar product, right? It's a triple product. It's called a triple product. For that, I will bring one diagram, right? Let me bring that diagrams. So what we are going to discuss here, triple uh, triple scalar product, right? Okay, right. So let me bring one nice diagram here, because rather than wasting my time to draw that diagram. Yeah, in this diagram, actually, what we are going to discuss here. So far we discussed the meaning of the cross product, right? So let's say one vector along this direction, that is a b vector, vector b. Then this one is vector c, right? Vector c, the angle between these two vector is theta. Then this is actually the parallelepiped, right? It's a three-dimensional parallelogram. It's parallelepiped. uh, so now the cross product between B and C, B cross C, actually it will give you the area of this one, right? Okay. So now what I'm going to do, I'm going to multiply this one with dot product with vector A. Okay. Just now we discussed, if you multiply, that means one vector dot product with another vector, actually it is giving the projection. Okay. Projection. But if you and in that case, if you calculate exact projection, the vector must be unit vector. If it is not a unit vector, it is not giving exact projection, but it's giving the vector along that direction, right? So for example, you could remember this one, right? In case if A is not a unit vector, this vector is not a unit vector. I'm talking about this one, right? If this vector is not a unit vector, this vector is not a unit vector, in that case, it is not giving exactly b cos theta. It's giving a vector along this direction, but not this value, right? But again, the dot product actually the projection of one vector with others. So now, in this case, because b cross c, one vector, that vector is perpendicular to the plan of B and C, the vector making one plan, right? Two vector, B and C is two vector. It is making a plan, right? A plan. So B cross C actually the perpendicular vector to this plan. Okay. This will be somewhere here, right? Maybe this is that uh, B cross C. Here you can see I have shown that B cross C vector. Then we have another vector A. It is making alpha with this, right? Okay. So now if I write this one in the vector notations, I'm going to write uh, only the magnitude, right? Okay. So that means uh, first you know that one, right? The magnitude, it's also A B magnitude. It's A B, right? Okay. So This is, this is from the basic maths, right? Fundamental maths. You know these things, the property. So now, first I'm going to write the B cross C magnitude. So how can I write? B vector, magnitude of B vector, C vector, sine theta, right? Okay. So now again, A dot this vector, right? So, or else I will write one by one rather than confusing you a lot. I will write for the dot product first, right? A vector, then B cross C vector magnitude, and the cos angle between these two. That means this is vector A, this is B cross C, the angle is alpha, right? That is cos alpha. Right. So now A vector, now B cross C I'm going to write, right? So that will be vector B, vector C, and sine theta. Sorry. Okay, so this is only the magnitude of this one, right? B cross C, if you write B cross C only, magnitude of B, magnitude of C, sine alpha, sorry, sine alpha, right? Sine theta, sorry, sine theta, right? With sine theta, then En, right? So when you consider the magnitude, this En part will not come, right? Only the magnitude, right? So that's what I have written here. I'll bring this one. Okay. Right. So now this is, area, right? So this one is area of this parallelogram, right? Area of this one, right? Okay. So this one is actually area. So now mod of A, that means magnitude of A cos alpha. What is magnitude of A cos alpha? Actually this one, right? Okay. Magnitude of A cos alpha, that is actually the height, right? So now it is area into the height, right? Perpendicular height. Area into height, actually, the volume. Volume of parallelepiped, right? Parallelepiped. Okay. Yeah. Right. So this is one of the important things, right? Okay. Where we use this one in continuum mechanics, if someone knows finite element analysis, FEA, in FEA, after deformation, normally, if it is three-dimension element, we discretize with three-dimension case, right? Now, after deformation, this vector will change, right? Okay. Okay, that means this will be the before deformation, it will be like perfect cube. After deformation, this cube will deform in in some way, right? In a different way. In that case, these three vector, that vector associated with its side will change. Then you can calculate the volume of that deformed element, right? Actually, the model I develop in my principle is based on the density. Actually, I included uh, my principle as a finite element. I applied in the finite element. I regularize uh, using this approach, right? Okay, but this is very important, right? Again, because of this is giving the volume, even though if we change the order of this A, B, C, because of it gives volume, it will be same, right? That what I mean. That mean A dot B cross C or B dot C cross A C dot A cross B is same because it is a volume, right? In all cases, it is gives only the volume of parallelepiped, right? So this is the properties of triple scalar product. Okay. Now, what is our next things? Let's write our triple product, scalar product in terms of uh, index notation, right? Okay. So if you want to write this one in index notation, because in my case in in the my style is and all the equation I will explain you in the index notation, right? Because uh, so personally I like this notation very much because it helps me a lot. Right? Most of the things I could able to derive uh, manually, right? Because this equation because it helps me a lot to reduce writing more number of equation, right? Okay, I'll write it for only one case, right? You can check. Even you can derive this one using index notation. You can write this index notation of first part, index notation of second part, third part. Then finally you will get the same uh, answer for all three cases, right? So let's take A cross B cross C, right? A dot with B cross C. So now we will write index notation AI EI, right? The first one. Okay. Dot. So I will use large bracket B uh, B, right? So now I told you we cannot write now I again because I cannot repeat it more than two. So now you have to write it some other one, right? BJ cross. Again, now you cannot use J here. So for C vector, I will write CK. Okay. All right. So now we'll simplify one by one, right? Okay. I'll keep it the outside one as it is. Dot product. The inside one, BJCK, it's just a number. Just is a normal multiplication. BJCK. Then you will end up with EJ. Okay, I'll write it EJ cross EK. Okay. So now AI EI dot product with BJCK EJ cross EK. You remember this one. Uh, epsilon JK. I will write LEL, right? Okay. So you remember this one, right? EI cross EJ epsilon IJK EK, right? So here, what is this first two subscript? It is actually the subscript from the vector, right? That's what ij. The finally you have to add another vector. Here, first two j and k, same. So another one, I have to add another new vector, right? I cannot use I here because I already is here. Then I cannot use j also because if I use j will be three times. I cannot use. Therefore, I will use L. Okay. Yeah. So now everything is done, right? So now let's say now we will do it for dot product. Dot product first I will take the scalar everything same. So these everything is scalar, right? Epsilon jkl again scalar because you know the values is -1 or +1 0, right? It's a scalar. So therefore you can take that everything like a normal multiplication. AI bj ck epsilon JKL. Now EI dot product with EL, right? Okay, right. So now AI, BJ, CK, epsilon JKL. Now this is, chronicle delta, right? Delta IL. Okay, so I am using this property, delta IJ. Okay, I and J from here, right? So here INL, I will write INL. So now we studied, right? Earlier. What is that? AI, BJ, CK. Now you see chronicle delta property. What is chronicle delta property? Take the common index, replace with another index in the delta. I have to replace with I, right? So therefore now I will write this one now, epsilon J K I, right? Okay. So now you remember I J K. If it is this notation, everything is plus one, right? So J K I and I J K will be same, right? I can rotate. No issue because both are plus one, right? So therefore A I B J C K I J. So this is the index notation of triple product, right? Then also you can see if you simplify this one, this will be like our determinant, right? So that means I think, yeah, yeah, this will be this one A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, so this is the triple product, right? Oh, okay. So let me stop this video at this point because we'll do it uh, slowly, right? We'll do it slowly and part by part, right? No need to do everything at once, right? Okay. So let me stop at this point. Then see you in next video. Please subscribe and share with your friend circle, right? So if you know someone who is studying in masters or PhD, even some people who are interested in mechanics, they will take during their undergraduate, right? I don't know whether you'll study this much of details. Anyhow, definitely it will help you in the future, right? Okay.